Alright guys, the goal of this lesson is to be able to take all that we've been talking about, quadratics, and graphing them and what they look like, and be able to apply it to contextual situations. So I get a lot of you that ask me all the time, when am I ever going to use this? And so we're going to be looking at how quadratics apply to the real world and when we might use them. So as we work through this lesson, just know that by the end, you need to be able to explain how to find the maximum height of a given object in context. So what does that mean? By the end of this lesson, you should be able to take this scenario of a ball is being tossed in the air from 5 meters above the ground, and it has a velocity of 30 meters per second and reaches a height of h feet. You should be able to do these 5 things with that. To be able to write an equation, find the height of the ball after half of a second, find the maximum height of the ball, and find out how long it will take for the ball to hit the ground, and then also be able to understand why both roots are not included in the solution. Alright, so the first thing is I just want to revisit a quadratic graph. So in this case, this graph is starting in the first quadrant at 1, 0. It's going up to its vertex and down at 9, 0. So what is the maximum point? What is the axis of symmetry? What are the roots? What is or are the values of y when x is 2? And what is or are the values of x when y is 2? So I'd like you to pause the video and just analyze this graph and answer these 5 questions. Alright, so hopefully you were able to get the following answers. The maximum point, we also call it the vertex, is at 5, 9. The axis of symmetry is that line that goes down the middle, so it's when x equals 5. The roots are at 1 and 9. And the value of y when x is 2, so I go up from x is 2 up to the quadratic and y is 6. And then the values of x when y is 2. So when y is 2, it actually happens at 2 places. And I put about 1 and about 9 because 1 is going to be the root, and so is 9. So it's a little bit bigger than 1 and a little bit smaller than 9, but we can't tell exactly, so that's why I put that. Alright, so now let's look at this exact same graph, but let's put it in context. So my x-axis is almost always time, and in this case we're talking about time in seconds. And here the context is this is the height of a soccer ball. So a soccer ball is being kicked, it's going up and it's coming down because of gravity. So now I'd like you to pause the video and see if you can look at this graph to answer any of these 6 questions. Alright, so hopefully you were able to analyze the graph and see that a lot of the questions on the first slide are now in context, but they're the same answers. So the maximum height is 9 feet. I can see the ball goes up and comes back down. And how long does it take? It takes 5 seconds. So when it's at 9 feet high, that corresponds with 5 seconds. How long does it take before the ball is kicked? So time is 0, and the ball doesn't start moving or ascending until I get to 1 second. At what time markers is the ball at 6 feet? So here is 6 feet. It's touching at 2 and at 8 seconds. So 2 seconds and 8 seconds. And then why are there 2? Well, the ball has to go up. It hits 6 feet, goes up to 9 feet, and then comes back down. And so the second one comes from the descension. Once the ball has reached 6 feet high, how long does it take for the ball to return to 6 feet? So it's happening at 2 seconds, and then it's going back up in the air, and then back down at 8 seconds. It reaches 6 feet again. So from 2 seconds to 8 seconds is a passing of 6 seconds. And then from the time that it is kicked, how long does it take for the ball to hit the ground? So here's the ball on the ground. It goes up, comes down. So it starts at 1 second to 9 seconds. So this 1 second here, I can't answer 9 because it took a second before the ball was kicked. So from 1 to 9 seconds is 8 seconds. Alright, so I want to talk about these 4 things because they're going to be really important as we talk about quadratics in context for this first module of quadratics. So I want you to pause the video and I want you to write down everything that you know about the axis of symmetry, the vertex, the zeros, and just an ordered pair on the graph. Alright, so hopefully you were able to talk about the axis of symmetry being the line that divides the parabola into 2 equal halves. It's also the line where the graph moves from increasing to decreasing because the vertex is on it. So as it's going up, the vertex, which is on that line of symmetry, is where it shifts from increasing to then going back down. Or if it were a minimum, decreasing and then increasing. But our graphs and our quadratics in context are mostly going to be about upside down parabolas, so the a is going to be negative. All right, the vertex, it's the highest and lowest point or lowest point of the graph, and it's always a point, x and then y. The zeros are where the graph crosses the x-axis. There's usually 2 roots, and the roots are when y equals 0. An ordered pair on the graph, and this is going to be important that you keep this straight in your head. So it's obviously made up of an x and a y, and for the most part, what we're going to be dealing with, the x is usually going to be time, and the height is going to be the y value. All right, so this is the function that we use for we call them vertical motion models. It's just that idea of some sort of object going up in the air and then coming down. So you will want to write this down, memorize it. It's going to become your best friend. But you're going to have h of t equals negative 16t squared plus vt plus s. So before I tell you what all that stuff stands for or where it comes from, I just want you to analyze this function and what do you notice and what do you wonder? So for instance, your question might be, what does T stand for? Or maybe you have a guess. I think T might stand for whatever. But if you'll just take a minute, think about an object. Maybe it's on the ground, maybe it's placed on something, it goes up in the air and comes down, and how might that connect to this function right here? All right, so now I'm going to tell you that h of t equals negative 16t squared plus vt plus s, where t stands for time. Okay, that makes sense. So the input or the x value is time, which we said the x-axis is always labeled time. And the output, or h of t, so at any given time, the h is the height at any given time, so the output. So if I put in 2 seconds and I go through this function, it will tell me what the height is at that given time. So negative 16 will always be negative 16, and that accounts for gravity, because when an object goes up in the air, gravity is pulling it down. So the coefficient in front of the t squared variable will always be negative 16. V is the velocity, so how much force is being put into it. So it's the difference between if I drop something, so I'm not putting any force into it, versus if I throw a ball, I'm putting some velocity into it. So that's the V, and you'll be given these values. And then the starting height. So is the ball starting on the ground? Is it starting on the counter and falling off? Where is the starting height? So all of those values go into this function, and then we can use that to analyze different situations. All right, we're going to start with just a simple situation. You drop your keys from a window 30 feet above the ground to your friend below. Your friend doesn't catch them. So determine how long it will take for the keys to hit the ground. So here is the function we're using, h of t. So the function height of time as a function of time is negative 16t squared plus 30, which if you notice, there's something missing from there. So go ahead and pause the video. What do you notice? What do you wonder? And how do you think you should solve this? So we're actually going to come back to this slide in just a few minutes. So first let's look at a general model. So this is a parabola we've seen before. So I've got my roots, I've got my y-intercept, I've got my vertex, and then I just have a point. This is just any given point made up of an x value and a y value. So go ahead and look at these different descriptors and figure out where you think they might go. So for instance, this one right here, what is the maximum height of the object? So whenever I hear maximum, I always think vertex. So we're talking about the vertex, so up here. But is the maximum height going to be the x value of the y value? Well, if time is on the x-axis and height is the y-axis, then this question is going to be associated with the y value. All right, so go ahead and see if you can find where these other questions will go. All right, so hopefully you were able to identify the different questions where they go. So now I want to look into a little bit more specifically. So let's go ahead and start over here with 0. So this 0 gets thrown out because if you think about, we're only talking in quadrant 1 because having negative height generally doesn't make sense. Now there is below sea level, but for what we're working with mostly, going below the x-axis on the y-axis is not going to make sense. And time is never negative, so this 0 gets being thrown out for being too negative. Alright, so then let's move up to the y-intercept. So this is answering the question, how high off the ground did the object start? Which would make sense because we're talking about, did the object start? Well, start is when time is 0, which is why the y-intercept is there, because the y-intercept is when x or time is 0. Alright, so then we're going to move over to the vertex. So the vertex has two parts to it. It has the x value and the y value. So the question at the x value is, when is the object at its maximum height? Because the x is the time, so that's measured by when. And then the question at the y value is, how high does the object get? So that given point is when it's at its max height, so the time, and where is its max height, or how high is it? Alright, so then let's move on around. Any point on the quadratic is going to answer this question. So how high is the object after the given amount of seconds? So at 2 seconds, how high is it? That's going to be the coordinate that goes with that. To find that, we would plug given seconds into the function for t, and then that output would tell us the height. And so let's finally make our way down to the second 0, and that's the positive 0, because remember we threw the negative 0 out. Now, there might be two positive zeros if, like in the soccer ball example, it kicks off after time has started. But the positive 0 is going to answer the questions, when does the object hit the ground? Because remember, the x-intercept is when y is 0. So when the height is 0, which is on the ground, the x value, or the time, that will tell me when. We can also answer the question, how long is the object in the air? And then these green boxes are just to remind you that my x-axis is being measured in time, and my y-axis is being measured by height. Alright, so these are the questions that I ask myself as I think through these contextual word problems. So I always start with, what do I know? That's always a great place to start. So I'm analyzing the text to determine just given information. Always go to, what is the question asking? Because if they're asking for height, then somewhere in your problem they're going to give you the time. If they're asking for time, then somewhere in the problem they're going to give you the height. Which ties to question 3, which variable am I solving for? So once I determine what the question is asking, that's going to tell me if I'm looking for height or time. And then what will help me solve this? So what information from my knowledge about quadratics will help me get that answer? And then my last one is, have I used words from the question to answer in a complete sentence? And I'm telling you now, you need to label. So if your number has meaning in the problem, it has to have meaning in your answer. So don't just put 4, you need to put 4 seconds. Don't just put 172, you need to put 172 feet high at 4 seconds or whatever. But I need that complete sentence and the context of it. Alright, so let's go back to this question that I posed to you a few slides ago about dropping keys from the window, and let's use those questions to solve the problem. So the first question we always start with is, what do I know? So I could highlight the whole problem, but I want to pick out the important math information. So 30 feet above the ground is going to be important. My friend not catching them is also going to be important because that tells me where they end up. I also know that height is going to be measured in h feet after t seconds. So t is going to represent seconds and h is going to represent time. So then I move to, what is the question asking? So it's asking me to determine how long will it take. So my next question is, what variable am I solving for? So if I'm solving for how long something is going to take, that is time. So I'm looking for the time. So if I'm looking for the time, they will always give me the height. So when I think about how long will it take for the keys to hit the ground, so I'm looking for the time that's associated with when the keys are on the ground. Well, that is when the height is 0. But I also have this 30 feet above the ground, so that is actually my starting point or the initial height. All right, so let's put this all into the equation. So I know I have h of t equals negative 16 t squared. That will always be the case because that's talking about gravity. Then we add on the velocity plus times the time. Well, the velocity, if I am dropping keys, there is no velocity. So I could say plus 0t, but 0 times anything is just going to be 0. So we're going to leave that. And then the initial height is plus 30. So this is my function. And so if I'm looking for how long, I'm looking for the time that it will take to hit the ground. So I'm looking for essentially the keys are dropping, and I'm looking for when it hits the ground. So that's looking for the roots. So in my calculator, I'm going to type this function into the y equals. And when I do, and I see the root, there's a negative root and there's a positive root, I'm going to rule out the negative root, obviously, because I can't have negative time, and I'm looking at the positive root, and it's a little bit bigger than 1. So I'm going to put on here about 1 second, and tomorrow in class, we're going to talk about how I can use the calculator to calculate the exact value. So I'm going to say it will take the keys about 1 second to hit the ground. If you're curious, the precise amount of time is 1.36 seconds, but we'll talk about how to calculate that tomorrow in class. All right, so the second one is being able to find the height of an object at a given time. So what I'd like you to do is pause the video, and I'd like you to go through those questions and get as far as you can. So remember, I'm starting with what do I know, what is the question asking, which variable am I solving for, and what will help me find that. So go ahead and pause the video and solve this as far as you can. All right, so as far as what is important information, I have highlighted in green. What do I know about that information? I went ahead and wrote down I knew 128 would go in for V. And after 2 seconds, so that's when time is 2, how high is what I'm looking for. So I was solving for H. And then my second question, is the rocket going up or going down? So I used my function, h of t equals negative 16t squared plus 128t. Now there is no initial height. And there's no initial height because this rocket is starting on the ground. So how high in the air is it when it starts on the ground? It'd be like plus 0, but I don't need that. So then once I had my function, I simply plugged in 2 because I wanted to know what is the height at a given time. So given that it's 2 seconds, and when I calculated that out, I got 192. So after 2 seconds, the rocket is 192 feet in the air. And then the question is it going up or is it going down? And so when I looked at the graph on my calculator, I noticed that it's going to be 192 feet at 2 seconds, but then also again at 6 seconds. So that's where this question, is it going up or going down? So at 2 seconds, it's going up, and then it comes back to 192 feet on its descent down, and that takes 6 seconds. All right, here we're going to be talking about the maximum height of an object. So I want you to think about what you know about quadratics, and I want you to use those guiding questions and see if you can solve this question. All right, so hopefully you were able to recognize that this is the exact same scenario as the previous one, but just asking a different question. So all of the given information is the same. The first question is asking for how long, so we're looking for time. Does it take for the rocket to reach its maximum height? So I know that the maximum height is also the vertex, and I know how to find the vertex if I know the equation. And then the second question is asking what is the maximum height. So I use that same equation where I have h of t equals negative 16t squared, always starts like that, and I'm plugging in 128 for the velocity. It's a rocket starting on the ground, so it has a initial height of 0, so I would have a 0 there. So I used my knowledge of how to find the vertex from a quadratic, and so I used x equals the opposite of b over 2a, and I got 4. So then that answered the question, how long? So it takes 4 seconds for the rocket to get to its maximum height. And then what is the maximum height? So I took that 4 and I plugged it into the function, and I got 256. So it takes 4 seconds for the rocket to reach its maximum height of 256 feet. All right, so for examples 4, 5, and 6, we're actually going to cover those tomorrow in your CSGs. If you'd like to read through them and work through them and see if you can start getting an answer. If you're lost, I'd like you to please work through it as far as you can and identify exactly where you're getting lost so that your group can help you. So those are all the notes you need to take for this lesson. We'll talk a lot more tomorrow, so if you're confused or frustrated or anything, just keep pushing through, write down, and identify those places where you're lost. But I'd like you to have an interaction now. So what did we just talk about? What do you understand? What do you need to remember? What will help you remember it? Is there a picture you can draw? What questions do you still have? And I'd like you to rate yourself on these 3 main objectives under our big objective of working with quadratics. So can you find the amount of time it takes for an object to hit the ground? Can you find the height of an object at a given time? And can you work with the maximum or the vertex? So identify which one of those 3 you feel the most confident and the least confident, and then we will talk about those tomorrow in class, so your CSG group will be based on that.